Today we actually have three, I think, fantastic papers addressing petroleum markets. We're going to sort of start macro and work down to sort of micro-oriented or sort of region-specific oriented discussion, if you will. The first discussion will be led by John Ballantine. His paper is "The Oil Supply Curve is Not Smooth with Agent Heterogeneity, Modeling Investment in Oil Production Decisions." John, of course, is with Brandeis International Business School. After that, we will hear from Andrea Bollino at the Economics Department at the University of Perugia in Italy. Energy Security and Portfolio Diversification, GCC Exporters Perspectives. And we will wrap the presentations with Olivier Massol from IFP School and the City University of London. Energy trade sanctions and international spatial integration. What is the impact of sanctioning Iran? To expedite the proceedings, what we will do is we will hear each of the presentations in order. If you do have a question that is clarifying in nature, please go ahead and let me know. And I believe you can submit your question through the Q&A or the chat. I'll sort of keep an eye on both. If it's not clarifying, if it's a deeper question regarding the paper, the methodology, the approach, or the implications, withhold that one until the end, and we'll sort of weave that into a broader discussion about all three papers over the last half hour of the session. So with that, I am going to step aside and hand the screen over to John. John, the floor is yours.
Okay, great. Let me get my screen up. Things organized. Let's see. Okay, so this is, I'm presenting with my PhD student, and so he is the one doing all the complex programming, and I've been sort of providing the overall guidance. This is Mohammed Al-Yurar, and we have also been working with KAPSARC over the number of years and sort of doing this. And essentially the idea is what we're focusing on is an improved and hopefully different way of modeling. And while we're looking at oil supply, because there's a lot of information on oil, we've got fields data and producer data. This obviously is an approach and perspective that we can look at longer term. So I will sort of quickly go through some obvious background that we've all seen, kind of touching on scenarios and different models, and then look at what is obvious to most of us, which is essentially we've got a, the operators around the world are different. They've got different objectives, the NOCs, the IOCs, and we've got countries and everything else. And then we'll take a little bit looking at how to approach an agent-based modeling and what the simplified approach of that is, and how that kind of helps generate looking at boom and bust cyclicality in terms of investment and boom and bust in terms of prices, and how this is a framework that hopefully we can start to use as we go forward. So obviously we've got, and again, just looking at oil, but we could just do energy demand. We know it's not smooth, it goes up and down, but there is a trend line and it's going up. And as we know, when we look at the dynamics, so DSG, the dynamic stochastic equilibrium, we try to figure out what the growth of demand is and what supply is, and there are imbalances there. And as you'll see, we know there are lots of measurement problems in figuring that out. And so that becomes one of the issues, is how do we do that, and how do different producers around the country kind of balance that? So here is the interesting question as you look at it. This is real investment in dollars. Here we have in the blue is the total, and of course the orange there is OPEC, and largely OPEC's investment is lower, but they've got large fields, they're more productive, and so you can get more oil produced for the amount of dollars that you invest. But you see the cyclicality in terms of the prices and in terms of investment, and of course that means as you invest later on you produce, you're going to get imbalances, and lo and behold, guess what? Prices go up and down, and it's not easy to figure out what they are. So here is a broader picture of different approaches towards modeling and what's been happening. Again, you start with the OPEC era at the beginning of the 70s, and essentially, as we all remember, or those of us who are old enough, we didn't have a lot of information and data on that. We were then trying to deal with that and collect that data. And this is, of course, when the IAEA was formed and the beginning of these international organizations collecting this. And those of us, kind of came from the market structure perspective. And Edelman said, look at market structure, look at the different players and understand that. And then we started building these more complicated data collection models, IAEA, EIA, and and Shell, of course, which is the dynamic stochastic equilibrium. And then the models evolved, and Killian and Hamilton. World, we've got the VAR model, and we're trying to do that. And so this is the evolution of that. And then still we've got the Edelman sort of competitive strategy and market structure sort of working there. So there's a whole lot of different models and approaches, and it still doesn't work very well. I love this quote, this is Drucker from a long time ago, and he just reminds us this is really hard and we're going to miss it. And so this is, of course, we evolved towards scenario planning. And then also, and since I come from a family of artists and painters, and Jackson, my uncle who worked with Jackson Pollock, it's a complex world. Even though there are patterns there, it's not easy to understand. So that's where we are. We've got this challenge of trying to generate scenarios, put in policy variables, and try to understand what people are going to do. And we know that there are interactions we're not going to expect. You say, obviously, COVID is one of the big surprises. So here is, I think, a paper that was 2019 out of Berlin DRW. And what they did is compared scenario models of different groups around the world. We're looking at them. And I think the important thing to look at is obviously the differences, right? Primary energy demand, and look at that. I mean, we're talking 50% differences. And if you go green, the amount of electricity. So again, this is variations of the DSG kind of models, trying to figure out what we're going to do, in fact, what this conference is about. How is it, are we going to trend towards a carbon neutral world, and where and how that could happen? And do you end up with, this amount of electricity and therefore, changing coal? And so again, we all look at these scenarios and we try to understand the robustness of them, what the assumptions are. The question that I ask, and I think we all ask, is, okay, we look at them, how do we get there? How do the producers make the decisions? And again, sort of looking at, here's the Shell variations, and you see pretty strong, significant changes in the amount of renewables, and of course coal. And we don't have, they didn't put the new IEA, but the new IEA would be having a much less coal. And so again, looking at this is really hard. And then if you look at BP, they're going to say they're having an evolving transition. So stepping back, what you're really saying, if we're looking at the agents or the producers, in this case, I'm looking at oil, but any energy producer, what do they do and how do they make the investments? Again, very simple. This is kind of macro, but just kind of reminding us the low-cost supply curve is over here with our OPEC and Middle East. The higher cost is over here. And here are all the different producers. Here's shale coming in. There's Iraq. We had Iran shut out, and then you have Venezuela being closed down. So essentially, again, just kind of looking at the largest producers there, and you say, what are they doing? How are they investing, and why? So, what I want to focus on here, and what my PhD student is saying, let's look at agents. Let's look at these generalized agents around the world. And we're going to do a very simple agent description, which is OPEC, non-OPEC, and try to understand what their investment behavior is and what the production behavior is. So here, and so the whole point, and this is again sort of obvious that people who study this business, they're heterogeneous. They've got different production changes. So here's OPEC production changes, and you could put this into obviously barrels but the price changes. But obviously what you pick up here is look at the huge swings. Here's a low price And then you got shale coming in. I know it's a little hard to see there with the yellow. And if you look over here, so this is production, and look at the investment changes. Look at the non-OPEC investment changes. So again, and this is, 60, 70% of the world production. Look at the huge swings. So how do they make those decisions into what's going on? Average firm, so what we've done and what Mohammed has done is taken the average firm and said, what's their behavior? And so we sort of aggregate them. And as you can see, we've not weighted them, and we've weighted them by production and investment. Again, huge swings and differences in investment changes. And so here you see the OPEC, investment changes, pretty significant swings. And that again, so that I'm just trying to kind of point out the obvious things that we know now. Point is, in the oil business, people know the fields, they discover them, but that doesn't necessarily mean they produce. So time to build is when you're actually deciding to develop that field. So again, look at the unevenness of it. Here's OPEC, and they can, they're larger fields, it takes longer. Here's the non-OPEC. And now, so that's when you've decided to develop the field, but you may have discovered it way beforehand. You had the leasehold interest. And so then the question is, when do you develop it? So if you looked at the North Sea, Norway and Statoil has, claims in the North Sea, and BP has claims in the North Sea. So they've done it, they may have 20, 30 years, which is the horizon. They don't develop it. Again, look at the decision time when people decide to invest. So these are the number of projects. This is OPEC. So you've got a long period of deciding when to invest and how. And for the non-OPEC, a little bit shorter because you have to develop them more quickly. And so they're different pressures. That you might say that the non-OPEC are saying we want to get a field if it looks like money in it to develop it. Same thing. What we're doing is decision when you make the decision to invest and how quickly it happens. And again, what you're seeing is broad swings. So I'm kind of stating the obvious, looking at field level data and trying to understand how firms and operators behave. We're just doing OPEC, non-OPEC. We haven't gotten into the complexities of what's really happening. Okay, mean production change. So here we go. Is that this is what's happening here, and sorry, I just had troubles figuring out who to see. Okay, so here's the other part that's interesting. So this is basically, now we're saying we've got firms who have decided that they've got fields. When do they invest? When do they develop it? And again, this is off of field level data and looking at break-even costs. And so the red is investments, and I'm looking at different parts of the world. And what I'm trying to show here is, and what we're trying to show here is that there's a lot of, you can see the difference in the break-even costs. It's quite different by different parts of the world. And then there's a discretionary decision to develop it. Now, these break-even costs are based on, the current price. So we didn't do any price expectation sort of function or anything like that, because that can get quite complicated. What do you think the future prices are going to be? Then we're looking at the net present value, which is the net present value based on prices. And again, the point, what we're trying to say is there are discretionary decisions each of these operators and different people, different parts of the world are making, and a lot is left on the table. So and again, the North Sea is an obvious example, huge field. Statoil has had a 30, 40 year sort of process of when to develop it. It's helped to fund its equity fund and, and its overall strategy, and same with different countries. And so, and look, there's Middle East has got a lot of projects that it hasn't done. So that's all that we're trying to say, is that in generalized form, we've got huge differences in the cost around the world, and we've got big differences in the operators. And again, I put them into just three categories: OPEC, non-OPEC, and shale, because shale obviously has a very different time horizon than the OPEC, non-OPEC. You can break this into greater levels of granularity if you want, but it's just kind of looking at the simple world. So the basic thing is now, and this is what Mohammed's working on, is taking the structure of the agent-based structure and saying, okay, how does this work? How do we try to figure out what these decisions are since the 1970s, and how have the agents operated in making investment decisions, where they invest to create reserves, and then they make production decisions, to go into the market, and based on some simple expectation function of what's going on in terms of prices. And so what the difference in this model versus other ones is it's not a structurally econometric model. You've got basically just agents deciding back and forth, looking at other people's actions and processes, and how do they produce and invest. So while you have some sense of what you think demand's going to be, and you have some expectations of price, that's all. And we start off with a very simple expectation function. We're going to sort of say, okay, now let's look at this kind of framework with an investment decision and a production decision and see what happens. So again, what we're trying to do with this framework and model is show how we can get boom bust, how we can sort of simulate these behaviors. And we're starting with a fairly simple set of parameters. And then we have agents adjust and react to them. So as you know, in game theory, you may be being specifying the strategy. But of course, when you get a lot of different agents, it becomes pretty complicated. You might say Saudi Arabia is pursuing a market share strategy, or you might say the shale producers are, the quick net present value. They want to get the money in 2 years or whatever. So you've got a whole different group of things. We're just saying, okay, on a simple basis, let's say we're going to make an investment decision and a productive decision, and then see what happens. And the other important thing is the lags. It takes time. And depending on the field and everything else, it takes time to develop it and produce it. Shale is shorter, North Sea is longer. So that's all I've done here, is that there's some discovery. We develop it at some point later. It may take 10, 20 years. In shale, it may be 4 or 5 years. So you got very different time horizons with different lags and financial requirements. And then we're saying, okay, so here it is, just talking about the structure of this decision-making process. And this can apply to any energy producer. We're just doing oil because we've got a lot of data and information, producers, but we understand that. And then the geology of what field you have very much affects to what extent you've got flexibility in your production. And as you know, in Russia, they may have less flexibility because of the temperatures and things like that. Saudi Arabia may have more because it's got spare capacity. So here is what we're setting up and how it's working. Invest. When you invest, you create reserves, and then out of those reserves, you produce. Now, the real issue and challenge, and those of us in this business know that reserve estimates are pretty problematic and they're difficult, but nonetheless, the idea is that you got something that you can take oil out of, oil and gas, but we're focusing on oil, and there's a sort of optimal sort of production pattern. But that's the process. So here I'm just saying is, okay, we know that they invest if people think their prices are going to be high and you got a good present value, and we look at our own costs. So you've got the operating costs, you've got the CapEx costs, and you've got expectations. Really difficult to figure out what the company and operators' expectations of futures are. So we're just starting with a simple today's price. We know that's not what it is. Killian and other people tried to do other ways of trying to come up with expected prices. It's not simple and easy. Nonetheless, that's what happened. So there's basically an invested production function, which is the invested in production. looking at current market price, and then we see what happens in the market, whether you have oversupply or undersupply. And then that generates the price going forward. So and this is the programming aspect. It's kind of beyond my time training and everything else, but essentially it's moving from essentially agents are optimizing based upon what they think the price is going to be and how to produce, and they readjust. So this is like game theory, but we're not specifying what happens. We're not saying that I'm taking a market share. I try to figure out what the best one is. And so the agents go back and forth. And from a programming standpoint, you just set what we think GDP demand is. So you have to make some assumption about GDP demand. You also have to make some assumption about amount of money and financings available. Then you can invest, and then you. So here's the net present value. And essentially the idea is that the agents and all the operators learn from each other. They watch what each other's doing, and they're making, this is their revenue minus their cost, and they have some net present value kind of calculation. We don't know exactly what that is. We specify it in a sort of simplistic way. Then here's what we're doing. You produce out of what you got, and you've got some flexibility in that, and you have to specify a little bit what that production is. And again, as those of us who know this business, the extraction varies a certain amount, and then you've invested. And as you know, and as we know, in the past 3 years, there's been a huge drop in investment. And there's, this may continue given sort of the climate policies that are sort of being talked about and discussed, but there's still going to be a need for investment in different parts of the world. So what happened? So out of this model and out of this framework, we run that, is what we're trying to say, guess what? We can generate, price cycles because of behavior of these different agents. And I'll show you the different behavior, because agents respond to a demand shock or a supply shock, and then they make their own decisions. And so in the high price, which is the orange on top, you're getting a different cycle versus low price. And so, because again, they've made a investment decision, which creates reserves, which therefore then creates an over or undersupply. So look at this. And again, I apologize. I know it's a little hard to look at these graphs, but okay, so we have a demand shock. So we have a big demand shock, boom. Then this is the price reaction. This is again generated off these simulations of these different agents reacting. And then you see, and the point is, what we're trying to show is that, guess what? It's uneven, and the interaction of the agents with each other is uneven. So you get different prices and you get different production. And here is what happens. Different agents learn and operate and respond differently. So, some agents reduce their investment, and so you're seeing a big drop of investment here for some of them, and again and some increase their production. So the point is, we have a heterogeneous response, and then and I'm sure Kenneth would be asking this question: how does this match up to the data? And anybody is going to say, how do we then take this and then see how well does it fit to the data? And the answer is, working off the Borstein paper, which was sort of the basis of this, we can match pretty well on a moment's basis to the data. We haven't thrown in any complicated sort of control variables. We just have the investment behavior and production behavior, and then we're saying, given their response to what's going on in the market, how does this work? So we're just trying to do that without getting more complicated, without throwing in more agents doing different things. So we're not throwing in Iraq and Iran and Saudi in the OPEC mix. Obviously would be going on there, or Russia, which is sitting outside. And so we're just trying to say, let's look at this behavior. What do the agents do? And guess what? We can see why there's boom and bust in the market, why there's volatility in the oil prices, and we can see that the different responses. And that's what we're trying to do. And here's the other one, negative demand shock, which is what we just had. Lo and behold, you're going to have big changes in investment. And again, you're trying to do that. It's figuring out what that investment change is and how you're doing it. Where this is going is then you try to specify in sort of general probabilistic statement, how are the agents going to respond to such and such? So, and again, this is somewhat data-based, but clearly, you know, what we've gone through with COVID, we know that there's been a different response on investment in parts of the world, particularly the non-OPEC. Shale was a drop, and now we're seeing shale pick up because they're seeing the prices are going back up. And we haven't kind of thrown in policy variables. So that's how we're doing it. I kind of rushed through the evolutionary, you know, sort of agent model, but what I'm trying to show you that this is a structure that is not got fixed structural econometric sort of equations, which are based on past history, using that data, but then it's saying, we've got smart people, smart operators figuring out what's going on in the future and making their best guesses. And if this is a framework and model that work, then we can expand it. So that's all we're really trying to say. The endogeneity is part of what this business is about. And so when we see all those nice smooth graphs, we know that that's not the case. And then we're trying to figure out how do we respond and where do we go? Clearly, you would add more agents. Clearly, you start thinking about other sort of policy variables. And of course, our problem is data, right? You know, we don't know how people are going to respond to all these policy issues that we're talking about around climate. We don't know if there's no funding for hydrogen, what's that going to do? There's a whole bunch of other things. We've just looked at one sector where we've got a lot of information and data, but it's a more complex. So I think I've stayed within my 20 minutes. I went kind of quickly and I apologize.
That's great. Thanks, John. I don't actually see any clarifying questions. I have a couple that I'll wait until the end to ask you. Thanks for the presentation. It's stimulating. There's certainly a lot of fruit on that tree, so to speak.
Right.
There's definitely a lot to discuss. And the literature with regard to you know, the topic that you've engaged is actually quite deep. And one of the things that I would just encourage just before we move on is looking outside of the energy domain, right?
Absolutely, absolutely.
Some really interesting stuff on, you know, putty clay models and all kinds of, you know, interesting things with regard to investment and whatnot. But we'll definitely come back to that in a few minutes. Thank you very much.
Yeah.
Andrea, I want to turn the floor over to you. So take it away. You're on mute.
I can't hear you. Yeah.
I was saying that I was sharing my screen, if I can, okay, and present you my slides. These are, hopefully you can see the slides. Entitled Energy Security and Portfolio Diversification, GCC Exporters Perspective. Is everything okay?
Yeah, Andrea, there we go. That's better.
Yeah, for some reason I see that. For some reason I see that the connection is getting poor now that you get the floor. Maybe
yes, we have some issues hearing you.
When I share the screen with Zoom, something happens. Let me take away my for a moment. Let me take away my where is it? My video, okay. So maybe this way it's become better because I took away my video. Is that okay, better or not?
Yes.
Okay. Okay. So what I wanted to say, sorry for this delay, is to present you, if you're listening me Are you listening well still? Okay. To present to you this work that they joined with Phillip Galkin when I was working at KAPSARC last year. And that is a way in which we are considering essentially the optimal portfolio theory borrowed from standard financial analysis to
Can you open the screen?
Yeah, Andrea, can you maximize the screen? It's actually very small in the, so just maximize the, yeah, there you go. Perfect.
Sorry.
Thank you.
Okay, I'm sorry. Yes. And I should also slideshow. Okay. No. I cannot find, for some reason, I cannot find the typical, what is it? Okay. Anyway.
The current slide, I think you can do it on current slide here. Current slide.
Andrea, if you go down to the very bottom.
From current slide. Okay, yes. Okay, yes. Sorry. That's okay. So what I wanted to say now that everything is settled is a very simple thing. So I will take a little time because the idea is very simple and very naive. Essentially, we're taking the optimal portfolio theory as we teach to the students essentially the first year, and we try to analyze the energy security from the export viewpoint, looking at two indicators, the physical supply, so the quantity, and the price component, the price of oil, in the following way. We are thinking that energy security has been, we did this in a companion paper 2 years ago, energy security has always been an issue looked from the viewpoint of us importing countries. Energy security, we avoid disruption, we avoid geopolitical problems, okay? From the viewpoint of oil importers. After all, IAEA was established exactly in 1973 for that reason, you know, to try to understand how to ensure physical continuity and energy security to the developed world. Now, with this paper, we look at the reverse. What is the energy security from the viewpoint of oil exporters? Meaning they need, because they grew, because there is a macroeconomic background that I'm not touching, of course, so I'm very naive in telling you this one, but we know that they have, like the IMF, this is a background idea. The IMF is saying that they have essentially a fiscal balance. I mean, an oil price that should support their, you know, development, their view. In Saudi Arabia, the Vision 2030 is now using the resources not to support the current consumption, you would say, but future investment in diversification away from the oil industry. So there are a lot of issues that are interested in understanding what is the, you know, return essentially of the oil supply that these countries are giving to their customers. So our idea is very simple. We consider that an oil exporter has an oil export portfolio, which is characterized by positive return, which is essentially the growth rate of oil exports, because that is a value by growing export of oil. So look at how naive we are. We don't consider all the fancy investment issues that John Ballantine just addressed, you know, a moment ago. We are simply saying, imagine that whatever is the growth rate of oil export, the higher the growth rate, the better is the return for the country. However, the variability of the customers, that is essentially the variability of the portfolio of exports, has an associated risk, which is the variance of the exported quantities to the customer countries. We can do the same reasoning rather than in terms of growth rate of oil, in terms of the oil price. Yeah, have an oil price, we know oil is a commodity, so this idea is essentially stretching the notion of mean variance or return risk analysis, saying the average oil price that a country gets by exporting has also an associated risk, which is the variance of the individual export prices that you can get in the data banks that we have analyzed. We have taken the, you know, the international export analysis from the counterpart countries. So what we are saying essentially is this: Saudi Arabia, Kuwait, UAE, Qatar, and Bahrain have a portfolio of customers through time, and we constructed the efficient portfolio frontier according to the typical essentially Markowitz type of frontier analysis. I will show you the picture in a moment. Okay, so then we use this data to see if there is anything that we can understand in simulating some what if, some essentially scenarios that I will show you in a moment. So the model is a background that we all know, and I apologize, for the essentially the elementarity of what I'm saying. Optimal demand of export is a function of the world GDP. For each country, as you can see, okay, for each country, as you can see, total export is a function of the export to the J partners, those who are customers and customers. And we can make a growth rate. We use monthly data, I will show you in a moment. You can have a growth rate of total export and a variance in each period, a variance across the customers that are buying your oil. You can say the same thing for the price benefit, which is the average export price that we get from the typical export data banks or data availability, which is a function of the individual export prices. We measure this, of course, FOB. Now, let me tell you, there is a lot of simplifying assumptions here. So an oil expert like Ken or like John will probably have some how can I say reservation of saying that the oil that I export to different customers represents a portfolio choice, because it is a function of a lot of things that we know in reality are important, like the of course the API grade, if it is sweet or sour, what type of refinery is demanding oil in that moment in that part of the world, which will make the price setting important. Unfortunately, we cannot address all these things, but we so we apologize again, simply presenting you the theoretical model using data in the following way. There is a variance, as you can see, which is a weighted average of the shares of the covariance matrix. You can have a return, which is the weighted sum of the returns with the share SJ. So by using the standard Markowitz 1952 portfolio or whatever, the following improvement, you can say that the standard deviation is a function of the square root of the return. Remember, standard deviation here is the portfolio variance of your exports, and the return can be the growth rate in physical terms or the nominal price in dollar terms per ton. We perform both analysis by simply understanding that that if B1 and B2 are the frontier convexity parameters, in the mean standard deviation space, this parabolic function of efficient frontier represents essentially the frontier of the portfolio with minimum variance. So all we are doing essentially is this. We have standard deviation on the horizontal axis, return on the vertical axis, the how can I say the horizontal parabolic wing or a portion of the increasing part of the parabola is what is the admissible solution of your mean return analysis. Of course, if the position of this parabolic function is to the left, intuitively you have higher efficiency because you get lower risk for a given return. If the position of your parabolic function is to the right, as you can see in this picture, then you have higher instability because you have, for a given return, higher standard deviation. So what we have done was to take the data. I don't bother, excuse me, I don't want to bother you with the usual data that you know very well. I mean, we have taken essentially the data for these countries as classified under the HS code line 27 in the statistics. We've done some preliminary analysis, but I want to bring you to the fitted result of our equations. Very simple. As you can see, the parabolic shape of our export growth rate for each country compared or put in relationship with the standard deviation of the export growth rate gives the following results. I will spare you with the, the coefficients that are in the background, in the appendix of these slides, but this is the idea. And it's interesting to notice that, you see, Saudi Arabia has the most efficient parabolic function. And then following, you have the, as you can see, the Emirates, and then Kuwait, and then again Qatar, and I guess the last one is Oman in this picture. Bahrain, we couldn't get decent data. They do not have enough customers for oil. Bahrain is actually exporting not such a big quantity, so we couldn't get a significant econometric relationship. So this is a decent picture of the mean variance or the risk return analysis of the portfolio of the customers of these 5 countries. Okay, we have done the same thing using oil price rather than oil growth quantities growth rate. So on the vertical axis, we have the export price in dollars per ton. In the period, I forgot to tell you, the period goes from 2005 or something until 2018 monthly data. So as you can see, the portfolio parabolic functions, or the portfolio efficient frontiers, are very similar for countries like, as you can see, Saudi Arabia, United Emirates, and Kuwait. They are essentially more moved position to the right for the other small countries. Qatar is almost a linear function, and Oman is, again, as you can see, to the right. Okay, the black dot is the 2018 observed value. Okay, so just to give you a reference of where we put our econometric analysis. Okay, then we have tried to understand what is happening, considering the 2018, which is the last year in our data set. What is happening if you have certain shocks? Imagine that the Chinese demand is increased by 20%, and the exports to other markets remain unaffected. Or imagine that the United States imports reduced, the share, excuse me, United States import is reduced by 20% for each exporters, and essentially the exporters make up, redistributing among the other buyers in proportion to their shares, the exports. Again, third type of analysis, Malacca Strait blockade. Suppose that there is a blockade that essentially will make oil cargoes to travel 3.5 more days to reach the East Asian markets, which essentially leads to a 20% reduction in export volumes to that region as, a sharp shock. And then the other markets remain unaffected. So what we have done was essentially to perturb the matrix of exports and the covariance matrix of exports of each country in order to recompute what is happening. Okay, whether this is interesting or not, I will leave it to you, but that's what's happening. With the increased oil export of China, the export volumes of these countries, will change in the following way, and the standard deviation also will increase. It is interesting to notice that actually the standard deviation will go up, so there is a positive mean variance analysis result for the other countries, but not for Saudi Arabia. For Saudi Arabia, the standard deviation of the portfolio goes down. Okay. Then we have done the same when you decrease the oil export to the United States. We can find significant results only for Kuwait and Saudi Arabia, which are exporters to the US. The others are significantly not. So what is happening is that by essentially concentrating their exports more to the Asian rather than to the North American, Asian and European, rather than North American market, as you can see, we have some reduction of the standard deviation that is again of the risk essentially associated with the portfolio export of Saudi Arabia. Q8 is only 1%, so it's not a very big analysis. When you have a Malacca Strait blockade, essentially you have a reduction temporarily of exports of all these countries, essentially. And as it is understandable, it's a simulation of a world in which temporarily they export less, they reduce their standard deviation because they do not export toward all the Asian, Far East Asian countries, namely China and Japan, essentially, after the Malacca Strait. And so that is what is happening, okay? So these are very, naive and simple analysis. The idea is this one: because the export perspective has traditionally been underemphasized or sometimes even ignored in the concept of energy security, we wanted to see if there was a way of understanding the issue of energy security from the viewpoint of a measure, not a physical measure of, military protection or, security of channels of supply or whatever, but a measure of energy security in terms of risk. And the risk is associated, the concept of risk for an economist is associated with the concept of variance. So we try to essentially demonstrate that a balanced approach to minimize risk was actually undertaken by these oil exporters. That's the information we extract from this preliminary analysis. And this is what we essentially propose to you for your consideration as a conclusion of our study. Thank you very much.
Thank you, Andrea. That's actually very interesting and certainly
it's unconventional, right? So that's
yeah, absolutely, very timely. I mean, some of the recent work that's a scenario analysis has been done. For example, IEA scenario about a reduction in oil demand really driving a lot of very interesting conclusions regarding a path to net zero by 2050 has tremendous implications for major oil exporters. And thinking about this in those terms, I think would be really interesting. And it really does present a challenge even to think about what reductions in demand would mean using your approach through a scenario-based perspective. One thing that I will note before we move on, and maybe we can come back to this in the discussion during the Q&A. The Malacca Strait example, where you saw a reduction in exports and a reduction in the standard deviation for a country like, particularly for Saudi Arabia, that complicates the risk assessment, right? Because you're talking about a negative dimension in both regards. So certainly, reducing the standard deviation is good in terms of risk profile. And that's kind of a counterintuitive result, I would argue, with regard to a reduction in US demand is less diversification turns out to be good for risk exposure. But if it also reduces, like the Malacca Straits example, exports, then it becomes a little more complicated. I'd love to hear your thoughts on that when we come back to the Q&A. So keep that in the back of your mind. Olivier, I'm gonna pass the floor over to you.
Thank you very much, Ken. I'm going to share my screen in a second. And the discussion provides me with a good introduction to my work. I think my screen should be shared. I don't know. Can you see my screen? Yes? Okay. Thank you very much. So I'm going to, the presenting discussion offers a remarkable, connection with my talk, because in the end we know that sometimes there can be some politically motivated issues that affect the oil market and that affect trade and the trade of energy. And one of them is the trade sanctions. So we could have discussed about trade sanctions imposed against Russia. We could have discussed about trade sanctions against those many countries. But one of them has attracted our attention was the case of Iran. Of course, the topic is far less hot these days than it used to be a couple of years ago. So it's good because it provides us with an opportunity to provide some cold analysis, of what has happened and what occurred. And it's always insightful because we know that in the Iran plus US tango, there is some kind of bizarre movement, and sometimes we can see that a topic of sanction could re-emerge anytime. So it's always interesting to have an ex-post analysis. So what attracted us was the fact that, well, politically motivated sanctions, I mean, of course, they usually generate fierce discussions in the public policy arena, especially among people who are dealing with foreign policies. And usually you have a lot of discussions about what are these sanctions, how should they be implemented, what are the details of the administrative measures that are going to become taken by the countries who coerce a given country. But what is extremely interesting is the fact that when we look at the literature in energy economics, sanctions are not so much discussed, by the way, which is to me a bit surprising, because when we talk about Iran, we are talking about a major oil exporting country. And in fact, the impact of the sanctions has been so far not unstudied. This will be too much, but little studied, I would say, compared to basically to try to start the analysis by looking at the effect of the sanctions on trade integration, especially on non-sanctioning countries, because we know that the sanctions imposed against Iran were predominantly imposed by Western powers. I mean, of course, the US, but also EU or the UN, but there are also non-sanctioning countries, and it's always interesting to see and to observe how the sanctions have affected, their markets. And when we look at the literature on sanction, of course, we have a series of contributions looking theoretically as whether or not the targeted regime will change depending on the sanction imposed and so on. We have some historical surveys looking at whether sanctions have had an impact or not. And usually the historical surveys document a mixed rate for the sanctions. In a specific case of Iran, there's been a few studies looking at the effect of the sanction on either the GDP, inflation rates. Were more recently, I should have added, there has been also a study looking at health issues related to the sanctions. But the impact of the sanction on trade, participation of the country has been little studied. And so far, we have only in mind, regarding the recent sanctions, a study by AIEEE, who look at the impact on Iranian exporters, but it's for non-oil sector, meaning everything except oil and petrochemical. And well, obviously it can be an impact on pistachio supply, pistachio exports and so on. But still, I cannot help thinking that it would be interesting to somehow analyze how the sanctions have also impacted the price of energy-related commodities. And so typically, this will be what we are going to do. For those of you who may know my work, I maintain a long-lasting interest into natural gas. And so when we talk about Iran, we think, of course, about gas. And because of various issues that would be too long to comment now, we know that gas, Iran has a hard time exporting its gas in LNG forms. So Iran opted for an alternative way of monetizing its gas, which is to convert it into petrochemical. And over the last 2 decades, Tehran has developed a strong state control industry aimed at converting that gas into petrochemicals. And Tehran basically exports its petrochemicals nowadays. And basically, what is interesting is the fact that we'll basically skip that one and come back again. When we look at the various petrochemicals that can be exported, one of them is methanol, and because it's quite simple to convert gas into methanol, it's not so capital intensive, it's not so intensive into foreign technologies, so you can have a domestic industry processing methanol. And besides, what is interesting also is the fact that compared to LNG, where you only have something like 500 vessels transporting LNG, which are all monitored by satellite, in the case of methanol, you can transport it using chemical tankers. As you know, there is a huge fleet of chemical tankers that can be involved in that trade, so it's less vulnerable to foreign sanction, presumably. And it's also a profitable option when you do a variance portfolio analysis of the various options that can be done for converting gas into like as a LNG or other goods that can be converted out of natural gas. Usually methanol is the second best option after converting it into LNG. So it's a profitable option for a country wishing to export its gas resources. And so when we look at the sanctions that were directed against Iran, were clearly had an amplitude that was never matched. It was unprecedented. And it was the very first time in 2012, between 2012 and 2016, that petrochemicals were targeted. It was not the case before. And suddenly petrochemicals were added on the list of sanctioned goods. And so this sanction typically prohibited the use of Western controlled shipping or banking services. And for Iran and ships, it means that basically Iran had a hard time, or traders involved in the trade of Iran petrochemicals were not allowed to use traditional shipping insurances provided by the Lloyds, for example. So initially it was created, the sanctions were aimed at creating a de facto an embargo, but we have had some insight from the grey literature that basically there has been some ship-to-ship transfer of methanol at night. There has been some smuggling. And so a question of interest is whether there has been some trade deflection from Iranian exporters toward non-sanctioning countries. And we know that sanctions have not been implemented uniformly in the planet. We know that some Asian states, who import Iranian products like Korea, for example, have implemented the sanctions, US and Western sanctions and similar sanctions, whereas others haven't. And so obviously we do not have data for the volumes shipped from Iran to these various countries, but we do have some insight from the prices observed at this destination market. And so a question of interest is whether we can see sign of this trade deflection from Iran in the prices at destination. And a good way to look at this is basically because usually the national petrochemical company of Iran is reputed to operate as a special arbitrager, meaning that it shifts petrochemicals to the various destination market, and usually absent any sanction, this company is reputed to be the glue that unifies the market and that creates a unified price signals all over the world. And nowadays, it's not so much the case. And so a question of interest is whether or not the sanctions have affected the law of one price, or the occurrence of the law of one price on the methanol market. I should have added that methanol is traded at destination, and usually it's a homogeneous commodity with a standardized specification in the various markets. So the price differences between the price observed, let's say in Korea or in China or in India, should somehow reveal supply-demand conditions or shipping cost conditions, but should not be affected by quality differences. So let's have a look at the model. So the standard model, when we are having a special arbitrageurs that ship a commodity to the various markets, so a collection of markets, if that exporter behaves as a profit maximizing exporter, so it ships a quantity S to the various market, and of course, depending on the price it observes it, depending on the production cost and the transportation cost to the various markets. When we have the first order condition, we can play with this first order condition to derive a condition for special integration, which basically is the following: that the special price at destination should somehow affect the differences in the shipping cost from to these various markets. So absent any sanction, we should observe the law, which is equivalent of the law of one price from Marshall, which is basically the fact that the local price spread should be somehow constant and equal to those differences in the shipping cost to these various markets. But well, to test that, we could see that empirically speaking, it could be interesting to detect whether or not special integration occurs or not. And so we're going to use a classical approach to test the validity of the law of one price, which is a parity-bound model first proposed in agricultural economics by Sexton and others, which basically states that usually you have several regimes. One, which is an arbitrage regime, whereby you have special integration holding, so that the special price spread is equal to a transportation to the unit transportation, or the spread between transportation cost between the two markets. You have an outside the parity bound regime, whereby basically the special price spread exceeds by far the transportation cost, which means that somehow there is some bias to arbitrage. So whether this bias to arbitrage can be explained by sanctions, so has to be discussed. Or inside the parity bound, meaning that basically the special price spread is too low to justify an arbitrage between the two markets. And so we're going to test whether this parity bounds hold or not by measuring the probability to observe the various regimes. So regime one at the parity bound upper than the parity bound below, by positing that basically the special price spread can be observed by external variables, including a constant or trend, and we assume that, of course, if we have the regime one, we should have the special price spread being equal to the estimated transaction cost, transportation cost plus a normal residual. If we have an abnormal situation whereby we have a spatial price that is too large compared to the transaction cost, or estimated transaction cost, when we will have an extra residual here, which is supposed to follow a truncated normal distribution. So it's a positive term here, a positive random variable. And absent, of course, in the other case, it will be too low. And in that case, we also observe another random variable that is also truncated normal, but in that case, subtracted so that the spatial price is too low. And so the ambition is to estimate not only the parameters for the transportation costs, which have not so much an interest, but also the probabilities to observe the various regime. And of course, if the regime one is observed the most frequently, then we have a high degree of spatial integration. If the two others are observed, then we can conclude in a different way. So to do so, usually you specify the log likelihood function, and you estimate it by maximizing a log likelihood. It's a technical aspect. I don't want to go in that direction. Simply mention the fact that we are assuming that if the probability have remained constant all across the observation period, then we have lambda, and we're going to test a situation where the probabilities to observe various regime has shifted following the sanction and other sanctions. And so we allow for a shift in probabilities when the sanctions are imposed by using a dummy variable, so that when the sanctions are imposed, we have a possibly different probabilities that are allowed. And by comparing the two models and testing whether or not the restricted model, whereby the probabilities remain unchanged during the entire observation sample, provides us with some indication as to whether there has been some change in behavior following the sanctions. So we're going to focus on the application. Regarding the application, so we collected 118 sanctions. The period of the observation starts from January 2009. So this is basically imposed by the availability of data in India till October 2018, which corresponds to basically the reimposition of the US sanctions on Iran decided by the Trump administration. So we cannot go further. So in that specific time frame, we have a period between May 2012 till January 2016, and the decision to lift the sanctions on Iran, where 45 observations that corresponds to the sanctioning period. We take the prices in Asia because we want to observe the impact on non-sanctioning markets. So basically, the Asian markets that represent the bulk of the largest market for the methanol is in the Asia-Pacific region for sure. So we observe the market in India, South Korea. And we have also a price corresponding to the price for the Southeastern Asia country, which is reported by Argus that correspond to the aggregate of Singapore, Malaysia, and Indonesia. Sadly, it's not disaggregated at the country level, so we have to use this aggregate information. So when we compute the price spread and look at the model, we first estimated the simplest parity bound model, so assuming unchanged probability during before and under the sanctions and we estimate ex post whether the probabilities of the various regime is obtained. What is interesting is that we observe that for some countries, when we can compute the probabilities that a given observation was generated by regime 1, regime 2, regime 3, and we observe that for the various pairs, and we noted that basically assuming unchanged probability for some pairs didn't make sense, obviously, because we observed that, for example, a pair like Korea and China, which had exhibited a fairly high probability of being spatially integrated before and after the sanctions, suddenly was affected by trade barriers, and it's visible in the price spread. So we have a barriers to trade regime that becomes extremely dominant in terms of probability. So probably it's good to look for an alternative model where you allow for shifts in probabilities. And so when we look at that, we use extended parity bound model whereby we allow for a sudden shift in probabilities and tested for the validity of the unrestricted model. We found that basically the likelihood ratio test for the null assumption of no change in probability is firmly rejected for most of the pairs, meaning Southeast Asia and India, South Korea and China, South Korea and India. We have a firm rejection of the assumption of no change in probabilities. Whereas for China and India, well, in fact, it seems that nothing happened, and that the assumption of having maintained unchanged probability during the whole observation period seems to be valid. And it's very interesting because it corroborates insights from the Gray literature, claiming that as India and China have maintained their trade relationship with Iran, continuing to import methanol from Iran or maintain trade with Iran. And that seems to be quite the case when we look at the price spread, because it seems that nothing has changed between these two countries. For South Korea and Southeast Asia, we observe that there has been a mild rejection of the model, but it's not at the usual 5% level. So it seems that what happens between the various market pairs, Southeast Asia and India, South Korea and China, South Korea and India, or South Korea and Southeast Asia, deserves to be investigated. So we look at the probabilities. So what is they are reported here, either before the sanctions or absent any sanctions for the lambdas, or under the sanctions when we are reporting the delta. So recall that regime number 1 is the one where we have having a special price spread that reflects arbitrage conditions, meaning that there is integration being observed. And what is interesting is the fact that for the market pairs for which there is a firm rejection of the model, we observe that absent any sanctions, we are observing fairly high degree of spatial integration between the market pairs. So meaning that clearly this idea described in the grey literature of Iran shifting petrochemical and thereby integrating the markets for methanol is valid. But what is interesting is the fact that once the sanctions are in, we are clearly observing that it's a barrier to arbitrage model that prevails, meaning that clearly those countries like in Southeast Asia or in South Korea who have followed the Western sanctions have ceased to import Iranian methanol and thus have incurred higher prices for methanol than countries in China and India. For South Korea and Southeast Asia, it's a mild rejection, but when we look at the magnitude of the price integration, nothing has changed much, so I won't comment that much at that case. So the conclusion, which are still, it's a work in progress. So the first conclusion we can gain from that is that absent any sanctions, we had a rather high degree of market integration that was achieved among the Asian importing markets. But that once the sanctions are imposed, we observe that we had balkanization and that we have seen that the countries who were suspected to not have maintained their trade relationship with Iran have indeed maintained a fairly high degree of spatial integration. But that these two countries, India and China, have then decoupled, have had a price that was somehow decoupled from the other market pairs in Asia. So overall, these findings are consistent with the commentaries found in the grey literature, so that's not so surprising. Well, here is the thing I wanted to provide to the table by somehow attracting the attention of our community, on the need to look at what is happening when we are having sanctions, and it's something that needs to be maybe further investigated, because sanctions play a very large role in the energy markets, and it's quite surprising that not so much investigated in the academic literature looking at this energy industries. Thank you so much for your attention, and this was my talk today. Thank you.
Excellent presentation, Olivier. And I actually, I'm going to start with you. I'm just going to kind of dive into questions, and I'll kind of work through the group. But you know, the literature that you're feeding into is actually quite interesting. And you're right, in the economics profession, it doesn't seem to be explored quite as deeply as it ought to be, particularly from the implications for trade, with regard to implications for trade. But you know, one thing that I think would be really interesting, I just want to ask if you've thought about doing this, is trying to do a comparative analysis using your framework, where you're looking at different sanctions regimes, because you know, it's pretty well established that multilateral sanctions are more effective than unilateral sanctions, right? Because they create firmer barriers to arbitrage. But I think it would be interesting, you know, to maybe compare using the framework that you developed, different sanction regimes. And this would obviously involve different countries and different specific time periods. But I wonder if you've thought about that, because it does actually provide a pretty powerful message with regard to the effectiveness of sanctions potentially.
Thank you very much for this excellent comment. I mean, it's true that it's something that could be considered, especially once the US have started to, you know, to impose a sanction, but it was unilateral sanctions. In that case, we do not have seen similar sanctions being imposed by European states, such as, for example, the UK. And so the Lloyd's has apparently continued to provide insurance to the trade to petrochemical tankers transporting Iranian methanol. So yes, it would be interesting to go on and move on in that direction. It's simply that at the moment when we did the analysis, so it's an analysis that we did last year, we didn't have enough observation to look at this. But now it would be interesting probably to add a few more observations and looking at whether once the sanctions are unilaterally decided by a superpower, which are the United States, we do observe or not a different behavior. It would be interesting.
And for clarification, you're focused on methanol in the empirical analysis. Have you looked at crude oil? Have you looked at, I get the reason for natural gas, Iran, I mean, it's limited anyway, right? Because access to LNG. But in terms of what it's meant for crude oil exports, have you looked at that at all?
Yeah, we initially were obviously interested in oil. The problem with oil is the fact that we do not have, a trade at destination for the Iranian for Iranian oil. We have all of these issues of finding, comparable things. So we could have looked at maybe products, the impact on product, but it's something that we haven't done. The reason why we concentrated on methanol was basically because it's the largest export of gas-based petrochemicals from Iran. So that's why we have chosen this one, and it also has this good property of being traded at destination and having a standardized, specification, so that you do not have, this problem of having dissimilar, specification, which can be the case with oil products, as you know, depending on whether you are considering the Chinese market or the other markets.
Sure.
May
So,
I jump in on this?
Yeah, please.
Yes, of course.
Yeah, I think there are two interesting things. I did some work on Iran, and there's the investment field development. And as you know, there was, when the nuclear agreement was put in place, it looked like they're going through a production sharing agreement, renegotiating the production sharing, and there's about $400 or $500 billion that people thought that needed to sort of invest. And so the question, and the only people who I think continue to follow the investment were the Chinese in developing it, because, and as you know, there's all the Revolutionary Guard, but there's a kind of the investment in sort of redeveloping, Iran's the gas capability and its infrastructure. Other thing that is interesting, and again, one of my colleagues at Brandeis has pointed out, is the Belt and Road Initiative. This is more on the trade side. The Belt and Road Initiative has developed a whole port in Pakistan. So basically, Iran can ship to Pakistan and get its gas and into the pipeline and go to China. So there's and again, that's a kind of a trade flow, but it's kind of how do you kind of work around this? And and it's kind of because clearly there's working around it, and I was fascinated with the huge investment that China made in developing this port so close to Iran, easy to kind of ship there and then put it in the gas pipeline.
So John, you actually just hit on what the next question I was going to ask Olivier, because going back to 2007, 2008, we actually did some work on what Russian policy with regard to gas flows through the Ukraine would mean for long-term investments in the gas market in Europe. And one of the things we showed, and this is sort of looking at the long-term implications of disruptions that are politically motivated to trade, right? Sanctions certainly fall right in this category. One of the things we actually showed was that Russia lost market share in Europe for 30 years as a result of an action that happened for 3 to 6 months, right? So tremendous implications for investment. And I think that's an interesting extension of what would come out of Olivier's work. Andrea, please.
Yes, I would like to step in this conversation by actually telling you that my companion paper, although I was not, entitled to present it here, our companion paper that we did was the symmetric one. Excuse me if I take this time to tell you, we were considering the mean variance or the return risk association of major oil importers, China, Japan, Korea, and Taiwan. And we simulated a scenario of the Iran embargo. Okay, so what is happening? Let me read from our paper that I published last year, because it's interesting for your conversation. An interruption of oil shipment from Iran has an impact on Asian importer by increasing the risk of the portfolio of all the China, Japan, and Korea, all the Asian importers. And this also is the same answer that I can give you to your previous question. Because in a efficient frontier, risk and return are positively correlated, no? So when you increase risk, you increase the return. And so when you decrease return, you decrease the risk. That is what is happening. If you have a Malacca Strait, what is happening is that you have less export to that region. Therefore, by renouncing on some return, you also lower your risk. So the message should be understood, I think, if you accept this explanation or this consideration, the message should be understood that any, disruption, like a military or a whatever disruption, can have paradoxical a good immediate financial return, but is detrimental to the context of the, of course, the trade around the world. And here is happening the same. When we redistribute in our model the shipment from Iran to other exporters, so essentially the embargo of Iran is made up by other exporters, then the risk profile of Japan and Taiwan actually improve, because what is happening is that they are essentially substituting in their portfolio some sense more volatile country like Iran with a more stable country like Saudi Arabia. I make it this, as a qualitative example to show you how this risk return analysis can provide you sometimes, both ways associations when you start making as if analysis. So I hope this was actually for your conversation on the Iran sanction. It also answering your previous question about the Malacca Strait.
No, I appreciate that. I was actually going to make a connection to your work. I'm glad you did that voluntarily. The interesting thing, just if I could rephrase what you said, because that's what it seemed like was happening with the Malacca Strait example, is you're actually shifting the efficient frontier. Right. That's effectively what's going on. Okay. I wanted to make sure I.
Yes, I'm sorry. In simple words, yes, you're perfectly right.
No,
much more good English and simple words. That's what we have done. You're right.
Absolutely. Excellent. Let me see. So, John, I wrote down a question I had for you. And before I get into that, the question that you're getting into is a great question to examine, right? And it's one that comes up over and over again over time. I know in my energy economics courses, we talk about what drives cycles. Anytime you have very sticky upfront, large fixed costs,
right.
You need adequate incentive to execute. And when you start to move, it takes time, and then there's that misalignment, right, in terms of time, demand, and supply. So it's a phenomenal question. I think the way you're approaching it is very interesting. I do know that this question has been examined in the electricity industry as well.
Yeah.
Why I encourage you to sort of look outside the oil domain.
Yeah, no, absolutely. And the Europeans are much more multidimensional in the way they think about these things than those of us who are caught in these silos, right?
No, absolutely. So, I originally was going to ask you a question, and then you kind of got into it about the negative demand shock, right? And I want to kind of ask you a follow-on question to that, because I found that one very interesting, obviously, because it's very timely, right? We're coming out of the largest negative demand shock for oil markets that we've ever seen in sort of recent history, and understanding what the recovery looks like has, dramatic implications, not only for capital flows into the sector, but also what it's going to mean for supply-demand balance, future price. And I think today, WTI is over $70 again, and we're kind of seeing this migration up. And, their analysts have been predicting, a spike in the price of oil because of a lack of investment. And so it sort of begs the question, looking at the results that you generated. The first one I had is, how large a negative demand shock did you simulate? And then where do you see, because I couldn't really tell from the graph.
Yeah, no, I know. I apologize for the graphs. They're hard to read.
Where do you see the positive investment responses versus the negative investment responses because of the heterogeneity with regard to production costs across the domain?
So let's just, one of the control variables that we have not quite figured out how to do, and particularly in this negative demand shock, is the finance constraint and cash flow. So that basically you're trying to figure out, do you have the money to invest? And do you have the financing?
Okay.
And so that has become one of the big issues, and how to do that in a way that's generalizable, right? And as we all know, and particularly in shale, you know, that you've got the boom bust in financing, and now particularly with what we've gone through over the past 5 years, financing is not available.
Right.
And so, but again, and so we've just kind of done that in a level of profitability, and therefore you have to have some kind of financing constraint in there. Otherwise, you can't do that.
Agreed. And that's actually, I'm glad you raised that, because that was one of the points I wanted to ask you about, because, you know, when you look at the US shale space, you're seeing a tremendous amount of consolidation. I mean, it's sort of occurring almost at record pace now because price is recovering, right?
Right.
But, and that'll of course change capital discipline across the space going forward, which will be, you know, good in general for the way production actually commences. But more generally, when you look at North America, Europe, Latin America, Africa, Middle East, you know, capital access is defined differently in all these regions. And I would say that would be a tremendous add to what you're doing, because you know, ESG considerations are certainly relevant. Investor preferences, which are coming through very strong sort of shareholder movements, are very relevant. If you're talking about, you know, African NOCs, access to capital provided by, you know, international agencies is very relevant, and that matters. And of course, that leads to discussions about, well, capital is ultimately fungible. It's not, if it's not coming from one place, will it come from another, and what will that? So
yeah, I mean, China will
kind of right on the precipice of addressing all these things. So I'd love to see that. And I was actually wondering if you had thought about the capital.
Yeah, no, absolutely. Because it's, if you just assume, you know, limited total access to capital, this doesn't work, it blows up. So you've got to have a capital constraint and try to understand it. And we at this point have just done it from a cash flow and a, you know, sort of leverage standpoint. But your point, this of course, you know, runs into the data issues that we're going to be getting into, is what does ESG, what do the various sort of, you know, investment targets that the, you know, BlackRock and other people put on in, you know, with their portfolio, what is that going to do? We don't know. It's not, and so that's a fascinating question. There's no question, as we know, where the money is, right? The money, it's in Asia and the Middle East. So to a certain extent, you don't, and, you know, and this gets back to the sanction question, right? If you're not able to finance these joint ventures, then you got a problem, right? But absolutely, yes, that's
So we're running up against it on time, but I want to close with one question I think all of you can address that occurred to me as you all were all walking through your presentations. And it definitely ties to John, with regard to what you presented, the heterogeneity of costs across the landscape. You know, there is a difference between IOCs and NOCs. This question directly connects to Andrea's presentation with regard to security of demand effectively, and what that looks like. And Olivier, it ties to your question with regard to sanctions, because and barriers to trade in general. And so I'd love for you each to comment on this. I saw some recent work that was done by Rystad at their one of their energy transitions marathons that they recently did. And it was a really interesting discussion about the rents associated with existing assets, existing oil and gas assets. And when they put this up and they said, look, we're just going to assume a $30 price, $30 price per barrel of oil and look forward through 2050. Something like 85% of the rents existed in national oil company hands, which shouldn't be surprising to somebody who understands, you know, the oil.
Right.
And that naturally begs the question, if you start putting constraints on the ability to either access capital or develop or trade in the developed world, which is largely the IOC domain, does it actually matter? And what might that actually look like with regard to the future of oil markets? What production pathways might you know, ultimately come forth as a result of those constraints. And that's actually one you might think about doing a scenario on, John, actually, thinking about how constraints outside of OPEC nations could impact production. But it begs a really interesting question about the future of oil in general. And so I'd love for you each from your own perspectives just to comment on that before we close. John, if you want to go first, fire away.
John, yes.
No, and I'll just say this knowing full well that you're not, I know this is recorded, but everybody knows forecasting is pure speculation and we're all going to
Yeah, and when if you've sort of seen that DIW review of all the scenarios, it's really fascinating because making the transition to electricity and whether it be hybrids or EVs and how you're going to do that, talk about money, I just don't see how you're going to get there in that kind of pace. So this is why, and Olivier, you talked about this, the hydrogen, blue hydrogen, and what's happening in terms of the investment in hydrogen, particularly in cement and steel. Forget the electricity grid. I think that is, that's something we clearly don't know what's going to happen. That's clearly, if you look at the overall, energy demand picture, you've got to say which are the different sources, right? And I think the issue we all have, at least I do, is not to be prescriptive. I mean, obviously, a lot of what's being happened and put out there is prescriptive. I mean, the IEA's recent scenario was prescriptive rather than, I sort of look at what are the agents going to do? This gets back to your rent. Obviously, we know who has the lowest cost oil in the world, and we know what they're doing and how they're investing, to what extent there's going to be demand. So the big question is obviously what's going to happen in the two largest consuming parts of the world, right? Essentially China and India. India's lagging in terms of how quickly they transition and how they do it. And clearly gas is going to have a huge role, and it's not quite clear what hydrogen is going to do in that. But will they continue to subsidize EV and its solar and everything else in the grid? I think those of us who are more skeptical just know that if you look at those scenarios, are we going to go to the 60 million, 40 million barrel BP scenario, right, in 2040? I don't see that. I do see, and this is just an opinion, the fact that there's so much investment going on and looking at how to have, carbon neutral fuels. It's not the fuel source, it's the carbon, right?
Yeah.
And that's really what people, and we're all knowing, sitting at this seminar, there are a lot of bright engineers trying to solve the problem. And they're figuring it out and digging into it and saying, and I forget the deputy energy minister when I met in Saudi Arabia 4 or 5 years ago, said, the issue is carbon. He was a nuclear engineer. The issue is carbon. If we figure out the carbon issue, then the fuel source, then we can get energy, and the most efficient source of energy are, oil and gas, right? So that to me is where these scenarios are really problematic. How do we kick them and look at them from the different parts of the world? And the largest parts of the world with the largest demand is in Asia, right? We're going to become more energy efficient in Europe and the United States. And, what's the mix going to be? I'm not sure. It's clearly not going to be, tripling of electricity that some people are arguing, but it's going to be some kind of mix. Ken, you've done a lot of stuff, and your people have done a lot of stuff looking at how do you build the efficient grid out there with wind and, oil and gas and everything else and solar. So it's a fascinating set of problems.
Very.
And it's longer term. So, you say.
Very. Thanks.
So yeah.
Andrea?
Well, I thank you for provoking this question. Now, I had an answer in my mind to your question, which was related to our typical textbook analysis of the backstop technology. When the higher the price you make now, the higher the rent that you are addressing, the higher the probability of getting the substitute that becomes efficiently an alternative to your costly oil. Okay, but that would be the implication of my risk analysis. Essentially the implication is that the risk is that by increasing your return, you also increase the risk of having a backstop technology that substitutes you. However, with what John was saying, prevented me to give you only this answer and to make another line of speculation, considering the new Saudi Arabia idea of the carbon circular economy, in which they say, essentially, I use oil to ship to you a clean fuel, say ammonia, could be hydrogen, ammonia, whatever, because I reinject inside the carbon dioxide that is coming out of the refining directly in my fields. So I will ship to you a clean fuel. That means that we have absolutely no way to forecasting if, so I finish with this provocative sentence, if the electric car will be another Zeppelin. You see, we don't know. We do not know. We could just as well consider. You remember, and I'm not talking about the Led Zeppelin. We are old enough to remember the rock band. Zeppelin, in the sense of a technology that was, so promising for transportation, and then was abandoned because it was essentially too cost effective in terms of understanding. Are the batteries, really the most efficient way of putting hundreds of kilos or hundreds of pounds in a car, while you can use very light hydrogen in your tank in a secure way to continue to run your internal combustion engine or a fuel cell revamped? I don't know, because I'm not an engineer. But this is the questions that the rent that you are considering has a value in terms of a new technology that we do not know which will be developed 30 years from now.
Thanks, Andrea. Olivier?
Oh, thank you very much, Andrea, and for raising this question. I mean, Andrea, you pointed the traditional bottling type of reasoning, and that's also when you start anticipating the possibility of a backstop, then you change also your extraction behavior, and suddenly you try to somehow extract as much as you can before it becomes useless or valueless. So it's true also that when we are starting to impose this, I mean, the shift in supply behavior is going to be immense. I feel that I have the feeling that it will be hard to debunk the oil, even if I'm working at the chair's economics of natural gas, or I'm also involved in the climate economics chair in Paris. It's true that removing oil from the system will be hard because of that, because of this type of green paradox that you may have when you start having climate policies, and you start also triggering a reaction from the supply side that may also decide the countries that are involved to ship and to extract the oil when and make it cheap and affordable for countries who may be in demand of that, especially in China and in India. And I think that to further developments this will be difficult. That said, I also have some concern from a geopolitical perspective as well regarding, in France we have a huge share of the population that has some origin from Northern Africa, especially in Algeria, and when we know how oil rent has somehow has allowed the country to have some form of stability, whatever we think about the stability. There are some geopolitical implications also that will be interesting to follow if we were to exit completely the oil industry. And that's something that also has to be accounted for in the balance. So
I really want to underline what you just said. I mean, the geopolitics of our producing countries, there's a lot of people, and and it's kind of like we've got to figure out, whether we put it in fiscal break-evens or whatever, you've got to think about that. It's 1 billion, 2 billion people are going to be affected if you suddenly have those rents disappear, right?
No, absolutely. And I would love to continue this conversation. Unfortunately, we're up against it on time. John, there was a question in the chat. I'm going to encourage Krista Haltonen from Imperial College to reach out to you directly.
Okay.
By email, because that's a question that could probably take a little while to answer, because it looks like it's
very interesting. Very interesting.
It is an interesting question without a doubt. Yeah. But Krista, I didn't ignore your question, so hopefully you and John can communicate directly on that one. With that, I want to thank everybody for participating. Great discussion, John, Andrea, Olivier. I look forward to seeing you all in person.
Yes,
Time
yes.
we get together.
Yes, and can we also thank the mysterious lady that was, from the organization with
Krista,
the,
yeah, right.
with the
Yes,
mask?
right.
Thanks to her as well. Thank
No,
you.
Absolutely.
Thank
She
you so much.
definitely kept the show going smoothly. So
Right.
fantastic. But thank you all. And I look forward to seeing everybody hopefully sooner rather than later. And in the meantime, stay safe and stay healthy.
Okay.
You
Thanks,
too.
Ken.
Bye-bye.
Great.
Thank you
Thanks a
so
lot.
much.
Great seeing everybody.
Thanks, Ken.
Thank you. See you.
Right.
Thank you, John. Thank you, Olivier.
Right. Thank you.
Bye.
Thank you,
Thank you.
Ken,
Bye.
especially. Thank you.